Fine, then let us begin. So
Right.
I'll firstly introduce you with the user interface. So is
Okay.
that okay, or you have already seen the user interface through the webinar sessions?
Yes, I think I've seen the user interface.
Okay,
Yes,
then we'll go ahead and start with the modeling in that case.
exactly. That's fine.
All right, sir.
But
So
before you
let
continue,
us,
may I ask, sorry,
yes,
before you
sir.
continue, may I ask this question?
Yes, sir.
Yes, apart from importing architectural drawing, I think you can also start by using grid lines to draw yourself. Can you?
Yes, sure, sir. That also is
Okay,
possible.
good. So these are the two I'm trying to get. Importing from architecture and then, so you can start now. Fine.
Okay, fine. Then we will do one thing in that case, sir. We will create our simple model, rectangular model structure with the help of grid lines. And we will also see how to model with the help of tracing files. So Mr. Pankaj must have shared with you a DXF file, right, sir?
Which file, please?
The DXF file, the drawing file.
Yes, he sent me a drawing file.
Yes. So we will also see how to use that drawing file. Is that all right, sir?
That is okay. Yes, let's use, but I don't want to practice. I want to listen to you and then practice later.
Oh, okay. If that's the case, then all right. I'm just checking if the session is being recorded. Yes, it is recorded. All right, sir. So this session is being recorded so that you can view it later on. All right?
Thank you very much. Yes.
Okay. Then I'll start. So first in the structure tab, we have got this grid line modeling option right over here.
Yes, that's right.
So we can, like, we have an advantage in nGen that we can use our grid lines to create our members as well. And these grid
Okay,
lines are in the 2D as well as 3D form.
that's
So
fine. Thank
yes, so we will click on this define or modify grid line, this command, and then we will be able to see a predefined grid line in front of us. However, this
Yes,
is just a preview.
that's right.
Okay. So we are going to be now providing the information for the X direction grid lines, X direction spacings, not the grid lines, but the spacings, and the Y direction spacing, and then the level. So first is the X direction spacing. So let's say we have got 2 numbers of span at 6 meters spacing. Alright, so this is like if you have equal spacing for 2 times. And in case
Right.
you have got unequal spacing, then you can simply provide a comma and write the next spacing. For example, it's just 2 meters, and then again you press a comma and then you provide a distance of, let's say, 8 meters. So in this way as well, you can go ahead and create these spacings in unequal direction distances. All right,
That's
sir?
right. That is right.
Okay. So what I'll do is I'll right now just give small examples so that we can go ahead with all the important questions. So I'll have, let's say, 2 numbers of story at 4 meters height, and then I'll have, let's say, a 3-meter story and then a 2.8 meter story, like that. So this is how the level I'm going to be creating, and after that I can also choose the location of my grid line. So that's about the base point. So this is the 00 is my base point right now, which
Yes.
is mentioned right over here. And now to finish with the definition, I click on apply.
Yes.
Okay. Now
Yes.
this grid line which you have defined can be registered, or you can actually see it in the model tree menu. Okay. So we have this model tree menu that has all the information with whatever we make inside the model. All right. So we have the grid over here, which is
Yes.
expanded, and we have grid set 1. All right, so then we have all these levels, and we have all the grid lines in the X and Y direction. All
That
right,
is
sir?
fine.
Yes, and
That
in
is fine.
case you would like to display, undisplay any of these grid lines, just uncheck these check boxes.
Okay, okay. And you get only a single one.
Yes, sir?
Yes, madam.
Okay. All right, so we are done with one grid set. Now we will press escape to come out of the command. All right. To go back to the same command, we can again press a space bar and we will be in the same command to define a second grid line, and we can have as many number of grid lines as we want. Okay?
Okay. Right.
All right, sir. So in case you would like to do the modification in the grid line, then you can go to this modify, define grid line modify, and then you can choose to simply select, like for example, I am pressing control and then I'm pressing the center scroll button to rotate my model. Alright, so in case I would like to do the modification in, let's say, the E levels, saying how we can modify the grid line. So for that purpose, what we are going to do is we will simply select any of the grid lines we want to, and then we can use either move or copy tool to add or move any of the grid lines. So if I use the move tool, then I have the option to just simply drag this arrow upwards and provide over here the information of the distance. So let's say I want to move it forward 1 meter. I provide the 1 meter distance and then I can click on apply. So in this way, my grid line has moved up. All right. Yes. Now I'll press escape to come out of the move command, and further we will go ahead with the convert into member command. Alright, so this convert into member command is where you can convert your horizontal and vertical grid lines into different types of members. So we have all these members that can be created, and depending on these members the designs will take place. So if I have to use beams, so here is the beam type, and then I have to also select the section property. So let's say the section property is 400 by 600. These are actually predefined section properties. I'll show how to define section properties as well. Alright, so I select this third section property, which is 400 by 600 mm, and then I'll simply go to the front view. So I press the middle scroll button to come to this viewing command, and I'll go to the front view directly. Alright, and after that I can simply drag around all the levels wherever I want the horizontal grid lines to be converted into beams. So as you can see here, the horizontal grid lines are now selected, and then I have to simply click on apply and continue. Alright, so this is how we have created the beams using the grid lines. Is this clear, sir?
It is clear, yeah, very clear. Thank you, thank you.
Oh, all right, sir. Then we will go ahead, create some columns as well. So again, I have to select the member type as column, and then go ahead to the section, and let's say it's SB 500 by 500, and then I can go to the front view and then simply select by making a box around the entire structure in this way. And in case I do not want any of the grid lines to be converted into columns, then I'll just simply click back on that particular grid line. So that's how it will get unselected, and then I'll click on apply. All right?
That is fine.
Okay. So this is how we can simply create the beams and columns using the grid lines. Now further, we have the option to also create the walls and flat slabs and also simple conventional slabs with the help of grid lines. Okay? So even if, for example, this is an example I'd like to give when we have flat slab. So there are no beams over here. I'll select these beams and I'll delete them. Okay?
Yes.
And then I'll go to the convert into member again. And then after that, I will use flat slab,
The flat slab.
and I'll use the thickness as 150 or 300 as required, mostly 150. So now I'll select all these horizontal grid lines, and we can see in the preview how the plates, or
Slab.
basically how the flat slab is going to get created. So I'll click on apply and we are done. Alright, so this is also how we can create a flat slab with the help of grid lines. Yes, sir? Uh, any questions, sir?
Okay.
Okay. So this is one thing. Next, let's also create our remaining
That is
slabs.
fine.
Okay. So for
Yes,
creating
madam.
remaining slabs, we can go again to convert into member, and we can use the slab type and then go in the front view
So
and
far, so good.
select. Yes, sir. So we can just simply
Hello.
select. Yes, sir. You're able to hear me, right?
Hello. Yes.
Yeah. Okay. Now here in the slab, we have got
Yes.
analysis
Yes.
type option. So in the slab, we have slab membrane type and slab plate out in type. Membrane type will
Yes, I
only
hear you.
take in plane forces, and plate will take out of plane forces along with the in plane forces. So
Okay.
usually when it comes to conventional slab, it is like a membrane type.
Please say that again.
So,
Say that again.
so I'll click on apply and continue to create the slab. Alright, sir.
Yes.
Okay, now here I would like to also mention that we can have these members which are created by us converted into other types of analysis with the help of this property menu. So here in the property menu, we have analysis type for that particular selected slab as a membrane, which we can
Yes.
convert into plate out in from here. All right,
Yes.
so this is how we can do the modification of the type of member or the analysis type, or we can change the thickness as well from here directly. Okay, so this is one thing. Now we'll go ahead. Grid lines is almost done. We will go ahead to the story definition, because this is also a very important feature when it comes to a building type of a structure. All right, so after we are done with the entire geometry, we can go ahead to define the stories. We can define the stories before we have created the structure as well. All right,
Okay.
but right now we have started with the grid lines. So first we create the geometry, and then we can go to the story definition. All right,
Okay.
so
Okay.
I'll click on this story definition, and here we have the option to set a story, like create a story set. Basically, we can have n number of story sets which we can utilize to perform the analysis in different cases. So that's one thing. So I have T1 story set. I click on OK, and after that I will go ahead directly to this auto generate story data. So I click on auto generate story data, and I will select all the members which I want to use in that story data information.
Okay.
Alright, and then I'll click on OK. The program will automatically detect all the levels, and then
Okay.
it will it will create the stories. Now here the story names are provided, which you can also modify. For example, instead of 1F, which is the foundation level, you can write foundation
Foundation.
here. Yes, and 1F level, 2F level. And this is Excel compatible as well, so you can just copy paste from Excel sheets if that is faster. Okay.
Okay.
Then
Okay.
further in this story data, you can also change the height of your building or your story. Okay, so the height of the story can be like modified simply by changing the value over here. Let's say it's 3 meters. Previously, I want to make it 3.5. Just change it to 3.5. Click anywhere else and then click on OK. So here, as you can see, the height of this particular level has also
Level.
increased.
Okay.
Yes. Okay, so this is about the story data. After you're done with this part, we will go ahead to the definition and then we will go to the member part as well to create more numbers of members. So here I'll go to the definition. Alright.
Yeah.
In the definition, we have firstly the material property definition. By default, two material properties have already been defined in the software. So let me firstly show you that in the model tree menu. So here in the model tree menu, we can go down and see the property section, and in that there is material. We can expand it and we can see that there is S275 for steel and C30 by 37 for concrete. These two properties are predefined. Now in case you would like to change these properties, you can simply right click and say modify, and the
Okay.
same dialog box which we opened while after we clicked over here is opening right now, and all you need to do is simply change the properties. So here we can like select various codes that are available, like we have American standard, British standard, European standard, and we have the the universal standard as well. And also we can like select the different grades of concrete. So let's say instead of 3037, we want to use 20/30, and after that, if you want to make any change in the model, in the elasticity data or the strength data, then you can simply change this code to like uncheck this button, and then you can do the modification directly
Okay.
manually. All right.
Okay. Okay.
So that's one thing, and then we'll click on OK. So in this way, we have modified the concrete property. All
Okay.
right. And now
Yeah.
in MIDAS nGen, the section properties and thicknesses, basically these properties as you see over here are directly linked with the material properties. So when you go
That's right.
for the 1D section definition, I'll firstly show over here, there are some predefined section properties like I mentioned earlier. So these in the bracket you can see the material property associated with it. So that's how you can understand which section property has which material linked to it.
Okay. That's right.
Okay. Then let's
Yeah.
click on this 1D section to start definition of the 1D material, section properties. Basically, we can have any shape defined over here. So we have certain section templates. There are steel section templates and there are RC section templates. RC will include solid rectangle and solid round.
Okay.
So this solid rectangle, you can simply provide this information, B and H information, and click on insert template section, and you'll have your section right over here, which you can again modify from this sketching itself. Like for example, if you do not want 400 mm, then you can change it to 230 or 200 and press enter. So in this way directly the section property is also modified. So that's one thing. Also, you can create any section by using sketching tool. So let's say, for example, we go to the sketch and we create like a circle in this way. And after that, we can also use options like trim. So you can trim this much portion, and after that we'll press escape from the keyboard and we can delete this section and also delete this line. And this is one section, so like an irregular section. So now I simply drag around this entire line, and then there is a small box that says define section. So I click on that define section, and this is how the irregular section can be defined. You can go to the define section, and then you can give it a different name as well from here, like irregular. And you can specify the material associated with it. And also you can have a different color for different section properties. And after you're done with this, you can just simply click on apply and close. Now when you want to make use of this section property that we have just defined, then you can click on that member and do the modification in the sections from here, or you can simply use drag and drop feature, like select the member and then drag and drop anywhere on the space. So as you can see now, this member has been modified. We have the new section shaped column right over here. Okay, so it will be better if we have an entire column, let's say, for this type of a section. So I'll just select and drag and drop the irregular property. Right, so like a different section that we have used. All right?
Yeah.
Okay. Now that was about 1D section. Coming to the 2D sections, that means the thickness. We can simply click on 2D thickness and specify the material, provide the thickness, for example 100 mm, so 0.1 meter, and click on OK. Alright, so that's going to be registered under the thickness area. So right now 150 is being used, 300 and 100 is not used. The one that is in blue color is being used by the members. Alright, so that's how we can understand how the properties have been assigned or not assigned. Okay, let's go ahead now to member tab, and let's see what all things we can create on this member. So I'll show one by one. Like we have got over here slabs. Alright, so remaining slabs we will create. So the conventional slabs, like the membrane type of slabs, they are going to be created with the help of the periphery beams. So I'll go to the front view and I'll select these beams right over here on the first and second floor, and we can see the preview, and then I'll click on apply, and this is how the slabs have got defined. All right, sir?
Yes.
Okay. So we are done over here with creating the different properties, main members basically. The other types of members that are there are braces, sub-beam, sub-columns. So let me just tell you about sub-beam and sub-column. So sub-beam...
Should I ask a question?
Hello? Yes, sir?
Should I ask a question?
Yes, sir. Yes, sir, please.
Yes, you can see that in creating your last two slabs,
yes, sir,
immediately you created them, it's showing the direction of the spans, the two-way spans or whatever. But in the case of the first one, that is the third floor, it's not showing anything.
Yes, sir. Actually, that is because it has yet not detected that it is placed on the beams, but it is placed directly on the grid lines. So when we go ahead to perform the analysis, that time it will directly detect the connection, and then it will be into one-way or two-way type. So that is one thing.
Thank you.
All right, sir.
That's fine.
For now, you can even click on that member and you'll see over here how the load distribution is going to take place. So you can even convert that load distribution one way to way likewise.
Okay.
Okay.
Okay. Thank you.
All right, sir. Now, yes, so I was explaining about the subbeam and subcolumn. So basically, subbeam and subcolumn are nothing but beams and columns having different beam end releases. So if you want to check what end release has been applied for the subbeam, then you can go to the Structure tab and go to the Global Settings. In the global
Okay.
settings, we have the modeling settings right over here, and in which you can provide the automatic releases. Like for subbeam, if you want to provide pin type of support for the subbeams, then you can select it likewise. Otherwise, you can make it as a normal beam, which is nothing but a fixed type.
Okay.
All right. So I've kept all the
Okay.
subbeam, subcolumns, and braces as pins so that it will be like the ideal condition I want to make it. Okay.
Okay. Okay. Okay.
All right. So I'm going back to the member tab, and we have discussed about the subbeam subcolumn, and after that we will go to also, yes, the wall generation. So wall generation
Mm-hmm.
also, we can use the grid lines to convert into walls, or you can also use the periphery lines like this. Okay. There
Okay.
are lines over here, members. So I've
Mm-hmm.
selected the periphery members, and then I can also specify the analysis type, like there is plate meshed, plate not meshed, and membrane type. So let me quickly tell you what these all three types are. So the
Okay.
first, plate meshed, is nothing but it will create plate elements which will be meshed by the program automatically. Then we have wall plate not meshed. So in this case, the program will create a plate, but it will not be meshed as such. There will be internal meshing as such created by the program.
No.
Okay, the wall plate not meshed and wall membrane are actually same type of members which are having rigid beam at the top and bottom connected by a wide column. However, the plate not meshed will take in plane as well as out of plane forces, and the wall membrane will take only in plane forces.
Okay.
All right.
Okay.
So
Okay.
usually we make use of plate not meshed or plate meshed depending on how you would like to perform the analysis. If at all you have got openings in the wall, then plate meshed would be required to be used. If
Yeah.
you have,
Yeah. Okay.
yes sir, if you have
All right.
already, yes sir, if you have already made plate not meshed or membrane type, and then you have applied a opening as well on the wall, then the program will
Mm-hmm.
automatically convert that wall into a plate meshed.
Okay. Okay. That's good.
Okay. So let's
Yes.
see how plate not meshed will be, and we will click on apply, and similarly we will create some more walls, and I'll select these. Okay, remaining ones I can also draw. So there is by draw feature, and yes, also you can draw the walls with the help of 2 points. So for that you can go to this story mode. I think you're known to these three modes: 3D, plane, and story. Basically, I would like to just like totally explain from the beginning. Like 3D, we can create the model and use the members in the 3D, but in the plane and story mode, you can only use the members that are in that plane or in that story itself. So let's
Mm.
see how to, like, yes, how to create the walls in the story mode. So we are in the foundation level, and now we will go ahead create the wall using 2 points. So when we click on wall at the bottom, we can see here there is one option, reference line and wall. So we need to basically select from here the wall, and then we will use this 2 points by 2 points option to click on one line,
Mm-hmm.
one location and the other location, and then you can click on apply. So not apply, sorry, when you click on 2 points, that time it already creates. So yeah,
Mm-hmm.
after clicking on 2 points, you can see now in the isometric view that your wall is already created.
Okay.
Now it's actually having 150 thickness. I'll change it to 300. All right. So
Okay.
I'll now go back to the 3D mode. We have over here our walls. This is again 150. I'll change it to 300. Okay. All right.
Yes.
And yes, lastly, I'll quickly go ahead and show you how to create the wall using grid lines. So it's simple wall selection is there. Thickness for the wall is done and the analysis type. Now I simply select the grid lines. It will be easier for me in this way. Right, so I selected these grid lines right over here. Okay, so this grid line is actually at this location. Anyway, no problem. We will click on OK. And we can also click over here and we can move our the location of our wall with the help of these points. Alright, so this is also how we can do the modification. Like stretching a member with the help of its periphery points. Alright?
Okay.
Okay. Now, one important part is that after you have created the story definition, then you do the editing in the model, then it is very much necessary to again go back to the story definition and select those remaining members or you can select the entire structure again and create the definition so that all the members will be included in that story. Okay, so this is one important feature. Right now, all these members are already there in the story definition. However, if there are any new members, then those will have to be also added. Okay, but it's recommended that you go ahead with having the story definition again so that you do not miss out anything. So I'll simply select all again and click on OK. And OK again. Okay.
Right.
All right. We are done over here with the definitions and the members as well. If you have any questions, sir, please let me know before we move ahead.
From this stage, where are we moving to?
From
Loading.
here, we will go to the body part. I'll explain how body is also utilized for creating the model.
Okay, so before we move to body part, can you add a cantilever slab anywhere so that we move on?
All right, sir. So for cantilever slab, I'll go to the...
Maybe on one of the floors.
Okay, all right, so no problem. I'll go to this plane, all right, so that I can create my cantilever slab very easily. And I'll create over here plate basically for the cantilevered portion. And I can use by draw command so that I can draw by myself by simply clicking on corner nodes. So I click on one point, let's say this is 1.5 or let's say 2.5 meters cantilever and 6 meters and back to 2.5. Okay, so this is the preview and I am using 150 thickness. Okay, instead of that I'll use 100 mm thickness and I'll click on apply. All right, so we have,
thank you.
All right, sir, we have over here a cantilevered slab.
That is fine. We can move on.
Okay. Now we will go ahead see some more modeling features. All right, like we have got body tool. So with the help of body tool, we can do a lot of things. Like we can also create the entire structure with the help of body. Body is like dummy elements that you might have used in any other program. So basically these are not going to be utilized for the analysis at all. These are, you can say, just for reference. All right. So like what all things you can do with it is like you can, let's say you want to have an opening in this flat slab. So for that, let's go to the plane mode. We'll go to this level. All right. And we will simply, sketch a circle. This is just for example, circle with a point. Okay, so I'm creating one circle right over here of 2 meters, then like the diameter. All right, and to see this thickness, to see this body, I need to uncheck or hide the thickness. So from here, I hide the thickness and I can see the circle that I just created. All right, so basically if you're creating any body on a 2D element, then you need to change this to hide thickness so that you can see it on your particular member. All right, so we have circles. Similarly, we can have arcs. We can also create like any shape, line. Okay, so I can use such kind of a shape as well, just for example. All right, now I'll go to the 3D again. All right, you can be in the 2D as well, no problem. All right, now I'll show how we can create opening in the flat slab. So I go back to the member and then from here I use opening command. And with the help of these circles that I've just created and also these lines, I can simply see the openings created before it happens and then click on OK. So as you can see here, we have got your openings.
Okay.
This is one thing. Also, I'll create one line on my flat slab just to show how we can also apply different loading, like line loading on the surface of our slab. Yes, sir. So I'll just make a irregular one so that it will be more like it'll cater to most of the needs. And then there is face type as well, which can be utilized for applying pressure load on different locations, like different pressure load at different locations. So this is another type of like a dummy area element. All right.
Okay.
So here, this is the body. And you can actually use a lot of editing tools in this, similar to AutoCAD. You are familiar with AutoCAD, right, sir?
Very well.
All right. Of course, yes. So all the intersection, extend, merge, divide, trim, split, all these commands are there. Also fillet, chamfer, explode, scale, extract, shell. These very frequently used tools are available for us to easily sketch. Also, we can have a 2D sketch on any of the plans. Like you can select any plan and then you can use all these commands to create your, let's say, your slab or your openings at that particular plane. Okay, these are actually very efficient tools when it comes to irregular modeling. All right, I'll get back to the 3D mode. Oh, sorry, finish sketch. Okay, and we are back to the 3D mode. All right, so this is done. Then I think we have seen pretty much everything. Also, yes, one more thing is that I'll quickly just show you that we can convert our body into members as well with the help of convert to member option. So if this is the line that I created using body, and now I can simply use the member as beam and the property, let's say it's a steel beam, and I click on OK. So as you can see here, that body line is converted into a member.
Now it's still be okay.
Yes, sir?
Okay.
Okay. You have any questions, sir, over here?
So far, so good.
All right, sir. Fine. I did undo right now to make it back into a body type of a member line. Okay.
Okay.
All right. There are actually many tools actually, but because of short time, I should actually go ahead and answer to your
It's
queries. So
okay. We
if you
can go
have,
ahead. I agree. We
okay,
can go ahead. Yes. Let's go ahead.
all right, sir. Fine. So this is until here. I have shown the different options to create the members. Now we will also. Do you also want to take a look at how we can trace the CAD files? Sir? Hello?
Hello.
Yes. Do you
Hello.
also want to check how to create the structure with the help of tracing files?
Yes, that is the architectural drawings, importing the drawings or what?
Yes.
Which one are you talking about?
So, yes. The architectural drawings. Like basically you can have any drawing which contain the columns and the center line of the beams and the periphery of the wall into members with the help of this function, tracing function in MIDAS engine.
Okay.
Okay, so
Okay.
there are like few things that we need to take care when we are doing the tracing file in MIDAS
Okay.
engine. All right, so I'll take you quickly
Okay.
into it. And firstly, let me open
Very.
up. Yes, sir. I'll
That's fine. I
open
said
up.
it's good. Very important.
Okay. So I'll firstly open MIDAS drawing. Okay, MIDAS drawing comes along with MIDAS engine itself. So
Yes, I've seen that one.
yes, sir. So it is important over here to open MIDAS drawing separately and not with the help of this option that is available in MIDAS engine, that is create tracing file. All right, this is
Okay.
actually just a temporary issue. There is a temporary issue in it. That's why I'm recommending to directly open MIDAS drawing directly from the desktop.
Okay. That's fine.
All right.
Yes.
Okay, 1 minute, sir.
No problem.
Okay. Alright, so we have MIDAS drawing file over here, and now to put any CAD file into MIDAS drawing file, we need to go to the file and say import, and then over here I will, yeah, this one itself. This is the file that I have shared with you. So I'll open this
Yes.
file. Okay, 1 minute. I think it is DXF file. Yeah, the plan is the file that I had sent you. I'll open that. Okay, now this
Okay.
is actually a CAD file having the periphery of the slab, flat slab, and it has also the locations of the columns, and the columns section property is also defined over here itself with the help of the periphery of the column. All right,
Sorry, may I interrupt you a
and
little bit? May I ask you this question a little bit?
yes, sir, please ask.
So, so this is not an architectural drawing. Am I right?
Yes, sir, this is not an architectural drawing. This is
That
the
is fine. Go on.
necessary, yes,
You
this
know, I
is
remain
the,
drawing, but yeah.
yeah. Sorry, sir, let me just tell you that this is actually the drawing which contains all the important features that are required in the tracing file. So you can have the architectural drawing with a lot of text into it and maybe the
You need
thickness
to
of
remove.
your beams.
Okay.
Yes, yes, sir.
You need to remove all those things from the architectural drawing and have only a basic center line, etc. Isn't it?
No, sir. No need to remove anything. For example, I have a line over here, all right? And this
Yes.
line is in, let me just click on this, okay? And we can see this line is in column command, okay? I'll change this into 0, okay? Or G region view like this one, okay? So I've put it into this layer. Okay, now this layer could be any layer, like any layer which the architectural drawings also have. Many layers they have. So you can have the entire drawing over here with n number of layers and any type of drawing in it. But the important part that should be there in that architectural drawing is the center line or the periphery of your flat slab and the section of your column, and these all should have layers, separate layers. Like I click on this line and this line is in the center layer. Okay, and also this one, like I have over here selected one line out of the column periphery, so it can also be a polyline, no problem. Alright, so here I have selected this line or the column elements, and they are under the column layer. So basically your architectural drawing should have layers for the columns,
Yes.
separate layers for the columns, beams and the
And
walls.
okay, okay,
Alright. Now,
okay.
after we open our architectural drawing or the structural drawing here, we use the command edit grid and press.
Yes.
Okay, so I write the command edit grid and press enter. And now from here, I select those layers which I want to utilize for tracing. So I'm selecting the column layer, put it under the column line list, center under the center line, and I use wall under the wall line. Alright, now this G region view which was there, I just created a line in between somewhere. So this one I'm not utilizing.
Mhm.
Alright, but
Okay.
even if I want it to be viewed in my drawing, like in my tracing file, just for viewing, not for any purpose, then I can put
Okay.
it under this undefined option. Alright,
Okay.
so
Okay.
you can see it, but you cannot use it like that. Alright.
Okay. Okay.
So now I click on save, and then I click on save again, and I'm using the name as new plan like that, and I save it and I go back to MIDAS engine. Alright, now here I
Okay.
go to this tracing file import and click on this toggle box to open the file, new plan, and open. And here I need to take care of the scale factor. So I have this particular drawing in meters itself. So, and my engine is in meters also. So I don't need to scale it down. I can make it as one itself. And then I can click on
Yes.
OK. Alright,
Okay.
this is how we have imported the tracing file. Now I want to utilize it. So I go to the define story. Alright, and there I can simply provide the information like that CAD drawing over here. Let's say I want to, yes, just for example, I will undo everything after that. So I go to the new plan and then I click on let me explain again. So this is the 2F level that we have, and in this 2F level there is CAD drawing column in which I can select the CAD that I have, CAD drawing that I have just traced, like imported. Okay.
Yes. Yes.
Okay, and after that I click on OK, and you can see over here in the 3D that there is a tracing file that is displayed, and to use that tracing file we will go to the story, that is 2F level. Alright, so this
Yes.
location of like this particular tracing file is already set in AutoCAD or the MIDAS drawing file, so that's why it is overlapping our already created area. However, I will be utilizing this portion to show you how we can use this tracing line now. Alright.
That that is fine.
Okay, so I'll go to the member now and I'll trace the columns first. So we have column member, select the material, then there is option to use by select, and then I simply make a box around my columns, and then we can see the preview. and then click on apply, and this is how our columns are generated or traced.
Okay.
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 Similarly, I can go
Yes.
to the wall and I can use the option to select the walls with the help of parallel lines. So wherever it is able to see parallel lines, it is going to create my walls, and also it is going to create the thickness as required. So this is how our shear walls and columns are created, and also I can have the beams created out of these lines. So I'll use this by select line segment option and just simply select these center lines in this way. Alright, just for
Yes.
example, and I'll click on apply. So in this way my beams are created, and then by using these beams you can go ahead create your flat slab or you can create your slabs.
Okay. Okay.
Alright, I'll just undo
That's
everything
fine.
so that we will not be have an additional structure here.
Okay.
Undo.
That's fine.
Alright, so this is done, and now we are done with the modeling part. We will go to the loading part. Before that, do you have any questions, sir?
No, it's hello.
Yes, sir.
Hello. Yeah. So it
Yes.
means if you have architectural drawing, you you
Mm-hmm.
you open the architectural drawing in the MIDAS drawing
Yes, that is right, sir.
before you import.
Yes, sir.
Thank you. That's all. I didn't get it. This has been my issue all along because I was
Oh,
importing the
you
architectural
did not get it.
directly to MIDAS without passing through the drawing.
Okay, that's why. All
So
right,
I
sir.
wasn't getting it, and that is why I've been complaining. But now you need to go through the MIDAS drawing. Thank you, thank you, thank you. I like that. Thank you.
All
It's
right,
one
all
big
right.
thing you've taught me. Thank you. Okay, we can
Okay,
go on.
okay. All right, sir. Let's go ahead then. We'll go to the loading
Sorry,
part.
before you
Yes.
continue, you can see that in the previous webinar,
Uh-huh.
when you were tracing or importing, you imported directly straight architectural drawing.
I did not show, maybe it was because of
I,
the time.
I didn't. Yes, I didn't get it that it was coming from MIDAS drawing.
Uh-huh. Okay.
Yes, so that was what confused. But now I've understood this aspect, so it's very good. That was why I was not getting my drawings to MIDAS. But now it's
Oh,
fine. I know it will come now. Thank you. Thank you.
all right. No problem, sir. I'll do one thing. I think many of the users who have seen that webinar must be having the same confusion. I'll add up that much portion in that webinar video and I'll resend it to everyone so that same problem will
Okay,
not happen.
that is fine. That is fine.
All right. Thank you
That
so
is
much,
good.
sir. All right. Fine. Shall we go ahead then?
Please, let's go ahead.
All right, sir. So we'll go to the loading part, and in the loading part, we have the sulfate command. So we have to go ahead, click on the sulfate command and then put it under a load set and then click on OK. Now this load set that you see here, static load set 1, is automatically defined by the program. However,
Okay.
it's automatically put into a dead load type, which is right. When it comes to sulfate, it is
Okay.
correct. But in case you want to apply live loads, then you need to create the load sets. So instead of like going ahead and coming back again and again for creating the load sets,
Mm-hmm.
we will directly click on this toggle button to open the
Mm-hmm.
static load set definition dialog box. So
Okay.
here now I can simply make my own names for my static load sets, put it under the load types as required. So dead load
Okay.
under the dead load type and live load under the live load type. Alright, we have many types of loads and all these loads types are selected as per the load combinations to be generated. Alright, so
Okay.
basically
Okay.
The program is able to create load combinations automatically with the help of the load types that you have selected.
Okay.
So I add the dead load, live loads, and that is it. I'll close this. No need of creating wind load and seismic load sets, because those can be automatically created by the program. All right. So in case you want
Okay.
to make your own load sets, the wind load and seismic load sets, then you can, of course, but it's not
No
necessary.
need.
Okay. So
Right.
we have dead load for the sulfate, and we have scale factor that is -1 in the Z direction, and then we'll click on OK. Now after we click on OK, we need to also once check in the analysis if the static load set, under the static load set, dead load set, and that under that as well we
Circle.
have the sulfate defined. All right. So it's like it's
Yes.
a good habit to basically confirm that whatever you have applied is also viewed in
It's
the
there.
analysis
There.
tree menu, so
Yes.
that it will be like perfectly correct in that case. Okay.
Check it. Okay.
All right. Next, we have different loads that can be applied, like there is point load, beam load, pressure load, temperature, displacement, arbitrary loads. All these different loads are applicable. And these loads, as you can see, can be applied with the help of the body. All right. Also directly on the members, but basically we have this arbitrary load that can be applied on the body. Like we have this line over here. So on this line, I can apply an arbitrary line load. So I select this body line. Okay, it's not a member, just a line on which the load will be applied, and it will be distributed on the plate or the flat slab. Okay, so here I'll just change this unit system to kilonewton meter for easy application. All right, so we have the option of uniform or non-uniform type of line load. So that's one thing. And here I'll provide a minus, let's say 5 kilonewton per meter as the line load. And you can see over here, this is a preview of the loading applied on this line.
Loading. Okay.
Yes. And also in case you have any trapezoidal type of loading to be applied on this line, or triangular or any other, then you have the function definition. So you can actually click over here and provide the information like with respect to X direction, Y direction, how you would like to modify the value of your loads. So it's completely like applicable, like any irregular type of loading can be applicable for your line loads. All right.
Okay.
So
Okay.
we have over here -5 uniformly loaded on this line. So I'll click on OK and finish with this dead load application on the line. All right.
Yes.
Similarly, you can like create points, you can create faces, like we have face over here as well. So I'll go to this unhidden, unhidden view, and I'll go to the load, arbitrary load, and pressure load, arbitrary pressure load, and then I can select this face, and on this face I can apply the loading. So here I can apply the loading in this way. This is a normal direction, so it will be like positively. You can see the arrow over here, it's upwards, so you can make it minus, and then you
Minus.
can
Yeah, that's
see
right.
over here, yes, so this is right, and then we can click on OK. So this is how we can preview, and then we can apply, so that we can be sure of what we are, or the direction of the load that we have applied. All right. Now on the flat slab, you can apply the pressure loading. So you can select the flat slab and you can apply the pressure loading like 1. Now here, this flat slab that we have created has its local axis, local Z axis in the vertically downward direction. So we can see over here that the normal type of loading is in the downward direction itself. So I've provided a 1 kilonewton per meter square pressure load for my entire flat slab. All right. So I'll click on
Mm-hmm.
apply over here, and also for the live load, I'll go to the live load set, and let's say provided 2 kilonewton per meter square pressure loading on my flat slab. Select it and I'll click
Sorry,
on
before
OK.
question. In this
Yes,
case,
sir.
the loading, is it not negative?
What, sir?
Is it positive or negative?
Editing the
The
load.
loading, the pressure you are applying to the flap is what?
Yeah, you're
Hello?
asking how to edit?
No, not edit. What I'm saying is that you were applying a pressure of 2. I thought it should be
Yes.
-2.
Yes. We can see over here the preview, right, sir?
Okay, okay, okay.
Yes. So it was like downward direction. It basically the direction type is normal. Normal as in it will
So
be
normal is downward.
perpendicular. Yes, perpendicular and opposite to the local z-axis of the member. For this phase, the
Okay,
local z-axis of this phase was going upwards instead of going downwards. So that's why. Sorry, going downwards instead of upwards. That's why it was we required minus sign over here. If in case you are not sure of the local directions and you want to quickly go ahead applying the loads, like using the negative sign, then you can change this normal to coordinate and use the Z. Okay, then you can simply provide the pressure loading in the global Z direction, that too in the negative direction. So you can then
okay.
press -1 in this case, select
-1.
the,
Okay,
yes, like that. Okay.
okay, okay. That's fine.
Okay, so that's one thing. Pressure loading is done, and also we will look at the slab loading. We have slab members over here. So for the slab, we will go to the slab load application. Now here the slab load has the slab load type. So slab load type as in you can have the dead load, live loads applied at once to the selected slabs. So you can have, here we need to provide the negative sign. So this is a global Z direction. Dead load of
Okay,
-1 and live load of -2 kilonewton per meter square. And I click on add, and we can have n number of slab load types generated at different locations. Alright, now to
okay,
assign this slab load, I go to the slab load command and I simply select the slabs and I click on OK. So in this way you can see over here the slab load has been applied to these two selected slabs. Okay, so similarly I can actually press spacebar again to apply the same slab load on all the rest of the slabs. So I'll select the slabs by simply unselecting everything. You can also select the flat slab. You can unselect, like you can select the load surface that we had over here. Also foundations we can create, and I mean that is a different part. But anyway, you want to select only the slab members. So we have this like filter of the selection. So I select only the slabs by making a box around the entire structure. Only slabs are selected. And then I do not want to select these two, so I click back on them.
okay,
And then I'll click on OK. So this is how I've applied the slab loading for all the remaining slabs. Okay.
okay.
All right.
Hello,
Now we will, yes, sir.
hello, hello.
Hello.
Please, can you go back to the application of the slab on all the slab loadings? Can you
Yes,
do
sir.
that again?
Yes, sir. So
Yes.
what I did right now is I used the option to filter the selection. So I went over here, and for this current function I can make selection of the foundation members, flat slab members, load surface as well. However, I want to
Okay,
apply the slab load only on the slab members. So I unselect
okay.
everything and only check on slabs, so that if I go ahead to randomly select any member or make a box around the entire structure, then these
Mm-hmm.
slab members only will get selected. You will not be able to select
Because
the
you have checked
found.
others. Okay, thank you. That's what I want. Okay, that's fine.
Okay. And I've unselected these
Thank
two
you.
because I've already applied the load on it. Okay.
That's fine.
All right. So this is done. Next, we will go ahead now to the wind load definition. All right.
Okay.
So we have over here assigned wind load option. So we click over here on assign wind load, we get to this command. We are going to apply the wind load on the story, so on the building, which is story based type of wind load. So that can be created with the help of the functions, design wind load function that we have. So we'll click on this toggle box to start with the wind load definition. We'll click on add,
Okay.
and then here we can select the standard. We have American standard, European and British standard. All right. So are you using European standard itself?
We use British and Europe, but you can use the European standard. It doesn't matter. Use the Europe or British standard, any of the two, British or Europe.
All right, all right. I'll use
I think we
Europe.
started with Europe. Am I right?
Yes, we started with Europe.
We started with Europe, so we have to continue. Okay. I think you can mix the two. Can you?
We can, sir. There's no problem.
Okay. Okay.
So here the average roof height will be automatically taken by the program from the story definition. And then further we have the parameters required for the wind load definition. So you can see that. And then there is structural factor. So there is one structural factor by default, but if in case you want to modify that, you can by simply typing in, or you can click on this three dotted box for the structural factor to be automatically calculated. However, you need to have the natural frequency of the structure for along the wind. So that is one information required, which can be obtained after you perform eigenvalue analysis. And that's what we will also do. All right, Sam. So right now I'll keep the structural factor as 1 itself, and I'll click on OK. So my design function is done. I'll close this dialog box and I'll use this design function, and we will have orthogonal load sets automatically created. That means we'll have wind load applied in the X, Y direction and the Y direction as well. All right. So for that, we'll have one scale factor for the major as well as the orthogonal direction. And before we go ahead apply this load, we can click on show profile to see how the wind load is being applied on the structure. So this is the story force, story shear, overturning moment, and we can see the direction orthogonal as well as major direction. Major is the X direction, orthogonal is the Y direction itself. So that's the thing. All right, if there is any additional wind load you would like to apply, then you can click on add over here, and you can apply those wind loads along the wind, and also you can have torsional load applied. All right, so that's one thing, and you can see the loads that have been calculated by the program. That is the wind force calculated by the program from here, which you can again export to Excel sheet to utilize it for your reports generation or any other purpose.
Okay.
All right, so this is done, and then we'll click on OK. So wind load in both the direction has been applied, and we can see these arrows in the X and Y direction. Okay. And also we can see over here under the static loads, there is wind load on structure, there is wind load set 1, and there is wind load set 2, I mean the orthogonal set. So this is how we confirm that the wind load is applied in both the directions. All right?
Okay. Yes.
All right. Next, let's go ahead and apply the static loads. So we have static seismic load. Again, it's going to be a building structure based type of static seismic load. And we can have orthogonal load set as well defined at the same time. The direction for the major is 0, minor is like orthogonal is 90. Then eccentricity can also be applied, like the positive, negative eccentricities as we require. If you do not want to apply any eccentricity, you can just change it to none. All right. This is about the accidental eccentricity. So this accidental eccentricity can also be controlled by clicking on this three dotted box, and then there is eccentricity option. You can have different eccentricities. However, as per most of the standards, we have 5% of eccentricity itself. So you can keep it likewise. So this is the accidental eccentricity in the major and the orthogonal direction. All right, and in case you want to also apply the inherent eccentricity, you simply need to provide the values in this table, and amplification factor also has to be modified from here.
Okay.
Okay, so this is done, and I'll provide 1 as the scale factor for the orthogonal direction as well. And we'll say show profile to see how the loading is applied. Oh, sorry, function has not been defined yet. Please let me click on this dotted box, and then we will go to the definition. Again, here we have American, UBC as well as European standard. So Eurocode we will select, and we will use the parameters required by the structure. Then we have analytical period option as well as approximate period option. So if you have performed the eigenvalue analysis, then the major period for the major as well as the orthogonal direction has to be provided over here. Otherwise, you can go ahead with the approximate period, which is based on the analytical formulae given by the code. So this as well the program can calculate. So you can simply click on the formula as required by the structure, and then click on calculate, calculate for the X and Y direction, and click on OK, and OK to finish with the design function. And then we will use that design function and simply click on OK to apply this seismic load in the X and Y direction. So that is shown with the help of these arrows.
Okay, okay.
Okay. So that's about the static lateral loads application. We will, do you have any other questions, sir? Like before we go ahead to the supports application?
No, it's okay. We will move on.
All right, sir.
It's so fast. Yeah, let's move on.
All right, sir. So we'll go ahead to the supports that is there under the boundary tab. So we have the boundary and we click on the support, and here we have the option fixed type, pin type, and if you want to, have your own definition, so you can even check off these boxes. So TX, TY, TZ is translational constraint, and RX, RY, RZ is rotational constraint. All right, sir?
Mm-hmm. Yes.
So let's say we are applying fixed support to our foundation. So I'll go to the front view. In the 3D mode front view, we will select all these bottom nodes and click on OK. So in this way, we can see that the foundation has, or the support has been applied to the members.
Okay, okay.
Okay.
That's a fixed support for the foundation.
Yes, right now it's fixed support for the foundation, but in case you have your foundation also created in this model, then you can use soil spring supports. And if you want to apply piles, then there is pile spring supports that can be assigned, and there is area springs in case you have a raft foundation. So all these options are available for soil structure interaction.
Area is for the raft foundation.
Yes, area is for the raft foundation.
And the soil support is for what? Soil spring?
Yes, it's a soil spring. You can apply it to foundation. Like you can create isolated footings in MIDAS and nGen itself, and then you can assign this soil support to those foundations.
So what type of footing are we using now?
Right now, I'm not using any footing over here. I'm assuming that the support is fixed. Just directly applying support to the structure. Yes.
Yes, I agree. But what I'm saying is that in the case of area support is for raft foundation. In the case of soil support, you said it's for isolated foundation. Is that right?
Yes, sir.
So at the moment, what type of support are we going to use? Isolated raft or what?
Oh, for
in this particular case, what are we? Yes.
Okay, in this structure, it's totally dependent. Like if you want to create foundations, we can create the foundation isolated footing, like isolated footing over here, and then we can assign the soil support over here.
Okay. Okay, then we should use isolated footings.
Okay, so for isolated footings, basically what we need to do is we can go to the plane, to this plane, and we can go to the member, and there is foundation. So here we can create by draw the foundation. So I'll just give an example over here. So I'm creating a footing in such a way. Okay, apply. Okay. This is just example, sir. So I'll create just
Okay.
one footing. Okay.
Yes.
All right. So I have a foundation over here, and then I'll go to the boundary. All right. And in the boundary now, I'll go to the soil support, and here I'll click on this three dotted box to define the function, or rather the stiffness for my soil springs. Now here we have the compression only type, so I can specify over here the stiffness in the Z direction and the X and Y direction, that is the horizontal direction. Alright, so that is one way. We also have the Joseph E. Bowles formula analytical solution for automatically calculating the horizontal and the vertical springs for the foundation. So you can simply specify over here the factor of safety, let's say 1.5, and the soil stress as let's say 200 kilonewton per meter
Okay.
square. And then further just check over here with the gamma value, which is a constant,
Okay.
and then further we can see over here how the program automatically calculates the vertical and the horizontal springs. All
Okay.
right.
Now, before,
And
okay, right.
yes,
O- Okay, it means if you want to design the isolated base, it means you have to sketch an isolated base on it, and then you move on with it.
yes, that is right, sir.
Okay, that's fine. That's fine. Go on, please. Go on. That's fine.
Okay. So then to assign this soil spring, I select the foundation and then I click on OK. So now we have applied the soil springs to our foundation.
Okay. Okay.
Okay, that's done.
Okay.
Let
That's fine.
me also look at supports have been applied, and we have also applied the springs over here. So yes, so we have undisplayed the springs as well in this way. Okay,
Okay.
so let's go ahead now and we will go to the analysis part. All right, and in the
Okay.
analysis part we can go ahead firstly with the analysis settings. So in the analysis settings, we can actually specify how the meshing should take place for our meshed plates, or our flat slab basically is going to be meshed. So for that we need to take care of the size. Now this size you can actually reduce it or increase it as you require. The accuracy, and then further we do also have the options to do the optimization. So this is at the last level, optimization level 3, and element size growth rate. So basically the program is going to take care of the nodal connectivity, and for that it will be orienting the shape of the mesh that is generated of the surface. So again over here we have option to have triangular as well as the quadrilateral type of meshing. Then we have the quadrilateral type as well. Mostly the triangular plus quadrilateral is utilized because this is used, triangular plus quadrilateral is used when you have curved plan, so curved surfaces. So for like with the help of triangular you can get like a very smooth curve, and you can achieve like more accurate result. Otherwise if it's quadrilateral then you'll get a little distorted curvature.
Okay. Okay.
Okay,
Okay.
so I'll go ahead with this, and yeah, there are many other options as well over here, like mid-side nodes are also available. This is in case of solid meshing, so for more accurate results. Alright, so that's thing. Then length
All right.
ratio criteria, this is 0.7. You can also make it to 0.1. This is like an aspect ratio. So that's the thing. And we have the
Length ratio
solver.
criteria.
Yes, sir.
Sorry, what governs the length ratio criteria?
Like the aspect ratio, basically what I mean to say is the length and the breadth of your element. It when it is divided, length over breadth, it should come to closer to 1, so that you get like a symmetrical,
Almost equal. Yes. Okay.
which is
Okay.
required for the finite element results.
Yes. Yes.
So
Okay.
for that is actually an important part for getting more accurate results. So that's why I
Yes.
mentioned it.
Very important.
Yes. So let's
Great.
go ahead to this solver, and for the analysis, like you can reduce the time required for analysis for big structures with the help of increase in processors, and also you can have GPU accelerator included. So these are like basically some functions that can help you increase the reduce the time for analysis.
Let me
Okay.
ask this question. So why don't we make it the default, the reduced time for the analysis?
If you have the GPU, you have NVIDIA GeForce card, and with that we can use the GPU acceleration, but then that hardware should be available with you. So if in case you have the hardware, the GPU accelerator, the graphics card as well, then you can enable the GPU acceleration. Otherwise, it will not be
Oh,
utilized anyway.
okay, 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 okay.
So we'll click on OK. And then we will go ahead with the combinations. So these combinations can be automatically generated by the program with the help of auto generation. So here we can see the ultimate limit state load combinations, that is the fundamental ones. Then there are serviceability load combinations, that is seismic, characteristics, frequent, and quasi-permanent. These are different types of load combinations as per the standard. So we have European standard over here. All right, and we'll click on
Okay.
add, and that's done. Also, we do have the option to create load combinations as per American and British standard.
Okay, okay,
Okay.
okay.
All right, so this is done. We'll click on close. We're done with load combination generation. Next is the static load cases. So here we can actually have many numbers of static load cases generated, so that let's say you want to utilize certain loading for one static analysis. So you can check or uncheck that loading, and then you can perform the analysis. So you can have number of analysis cases. All right, sir.
Yeah, that's right.
Okay, so click on OK over here, and then we will go ahead to run the analysis. So we'll select and then we'll click on OK. And I'll just save this file first of all.
Before you
Okay.
continue, the loadings that we did, we did it for only the flat slab.
We have
Is
applied the
it
loading,
only
not
to all
only
the
the
floors?
flats. Yes, we have applied for all the floors, sir. When we use the slab
Oh,
load
okay.
command, at that time we had applied the loading on all the rest of the slabs.
Okay, I didn't know. I thought the roof loading would be different from the other slabs.
Okay. Yes. I mean, we have applied pressure loading for our roof, that is our flat slab, and we have applied slab loading for the remaining slabs.
Okay, that's fine. Let's go on. That's correct.
Okay. So this
Okay.
is done, analysis is performed, and we can also see the mesh that is generated by the program automatically by clicking on this mesh and then looking at the mesh edge. So this is the meshing generated by the program on the flat slab. So you can see how the program has taken care to connect all the columns and also take care of the opening, and it has modified the orientation, and it basically did not have to worry about the connectivity with because of the automatic meshing that is available in MIDAS nGen.
Okay, that's fine.
Okay, so
Right.
let's go to the results. Now after we are done with the analysis, then this analysis results tree menu opens up, and in here you can simply go to that load case or load set, and then you can see the results for those load sets by double clicking, like displacement in Z direction. So I double click, and this is the result we have in front of us. Alright, so I'll just right click and undisplay all the bodies so that it will be a better view for us. Alright, so this is one result. You can see displacement in all the XYZ direction. We see the legend over here as well. And further over here we have the ribbon menu, which can give us the deformed shape. If we check on the deform, you can also see the real deformation with the help of real option right over here. And further we have the values, so you can actually see the maximum value on our screen. So that's one thing. Also you can see all the values by simply clicking on all, but that will be too much to see, so I'll just say max. All right, so that's maximum is 20. And in the legend right now we are able to see the values for the contour, and I'll just change it to mm so that we see better. Okay, so the maximum is 15.93. We were able to see 0.02 because it is rounded up to 0.02 like that. So 15.93 mm is the right value. All right, now we can go to different load sets from here as well. So you can go to live load from here, or wing loads, or you can go to the seismic loads, or you can go to the load combinations that we have created. And in that, these are many load combinations. Envelopes are available. So you can actually see the maximum envelope, which tells us that the maximum out of all the load combinations is 21.8 mm. So this is how we can like basically display all the results. So there is reactions as well that can be seen. You can see the vertical reactions wherever the supports are. So, and like all over here, so that we see the results at all the locations. All right, and further we have forces that can be seen. Yeah, basically I'll show the beam diagrams. So yeah, so these are beam diagrams, can be seen with the help of beam forces. So there is actual force, which we can see mostly for the columns. So here I'll make it absolute max, and I'll make it by member. So for every member it is showing me the absolute maximum value. Alright, so that's how we can see for the actual loads in columns. Then let's see the bending moment for the beams. So this is how we can display. Basically we can also select any particular member and right click and say show only to only view that particular beam. And then for that beam we can further see what is the bending moment diagram. So this is in kilonewton meter now, and I'll select by element. So I can see now the result at all these locations wherever the lines, straight lines are.
Yeah.
All right. So this is how we can check the results in the form of display for all these like basically cases. Then another way of looking at the results is with the help of tables. So you can also get the results in the form of table. So you go to this table tree menu, and in this table tree menu you can go to the analysis results, and you can look at the reactions table tree menu, table. And from here you can say all, so that you can see the forces or basically the reactions at all the node locations. Okay, this is for the dead loads, and you can change the combination, and any combination can be selected from here.
Okay.
All right. So that's about the table results. Any questions over here, sir?
No, so far fine.
All right, sir. Now we will go ahead to the design part. Is that okay?
Yes, let's go.
All right, sir. So we'll go to the design part now. And in the design part, let me firstly go to the initialization in the results. We'll click on initialize to see the entire structure. We'll say right click and show all the members. So we are back to our original model. Okay. And we will go to the design tab to start with the design definitions. Now there are a few important things that we need to take care of when it comes to design. So first thing is about the load combinations. They should be generated. We have already created the load combinations in the analysis tab, so we can go ahead. Okay, so load combination is one thing. Second important part is the design group. So this design group is required for creating the drawings. Alright, so this is the design group command. You can actually define design groups by yourself. For RC, select the beam and then you can create a set of design. So let's say beam, and I'll click on add, and further you can also create a design group list for the set that you have created, and you can provide any name to it as well. Let's say B itself. Alright, and once this is done, you can create similarly for the columns. So we have column over here. So this is basically you can have by yourself like any column load. I'll just make it C as itself for column, and after that I'll create one more for wall. So here I'll directly create a group for wall. I'll call it as W, and I'll create one for slab, non-set, and put it under the slab. Alright, and once I have created all these design groups, now I need to assign these groups to the members. So for that, we'll go to the assign group, design group, and then we can click on this dialog to actually see what kind of what kind of group we are assigning to the members that we have selected. This is manual. We have automatic option as well. Alright, so auto grouping is also possible.
Yes.
And then you can go ahead select instead of like selecting, you can click over here on this three dotted box, look at the prefixes that will be applied for different stories. All right, and yeah, so we're at the beam. Let me see the group name. Group name has been provided. Beam selected. Yeah, so here we have the beam, and then assign type is automatic itself, so no need to basically select them. Let's make it automatic itself. We can see the preview, and then we'll click on OK. Now need to do the selection as well, so select it and click on OK. Alright, so we have applied the beam groups. It's actually very faint. It's given in white color itself. That's why it's not that visible. But you can see over here there is beam number written, name 5 beam 1, like that. So basically
Yeah.
designations is done. So same thing we can do it for the columns. So I'll select columns, all the columns, automatic, group name. There is a group name created. And this is okay. It's better to make it manual then. Okay, so we have C, and then we'll click on these like all on the columns, and we'll click on OK. Except for one B column which is having a different section property, so I'll unselect those. It's not selecting. Okay, yeah, this is done. And similarly we have slab. So for the slab, I'll select the slab group, and we can, for now I'll just select quickly few of the slabs, and I'll click on OK. Alright, so we are done with assigning the design groups, and now we will go ahead with the design. So design cases, also similar to analysis cases, we can have a number of design cases. So click on design case, and over here it will show us with different groups that that we have assigned to different members. And also, in case we want to perform design of selected members, then you can click on select from view, and then you can select the different members for which only you want to perform the design. So I'll click on OK over here, and we'll run the design. Now the program is also capable of assigning certain reinforcements arrangement to the members. So for that we can click on rebar auto arrangement, and then click on save the modified data and close the dialog box, and then the program will perform the design. Hello? Hello? Hello?
Hello?
Yes, sir. You're able to hear
I'm
me,
here.
right? Okay.
Yes, I can hear you.
All right, sir. So here we have done with the design part. Now let's take a look at the results of the design.
Please,
So we have,
before you go for the results,
yes,
just
sir.
go over the design again.
Okay. So I was explaining how we can create the design group so that drawings can be generated. And after that, I created a design case. So design case is just like we have analysis case. We can create n number of design cases. So there was the design case for this analysis that we have performed. We can like select from the list different analysis that we have created and performed. And then over here we can also select members for which we want to perform the design. So if I uncheck the beam, then the program is going to perform the design only for the column, wall, and the slab, and the flat slab, and the foundation.
Okay.
Alright. So that's the thing, we have created one design case, and you can see that design case under the design tab, design tree menu. We have a design tree menu as well. There is a design case, and below that we can see the design case 1 that we had created.
Yes.
Okay. Then we go ahead to run the design, and we use this rebar auto arrangement. Okay, you've seen this.
Okay. Yes.
Alright. So after performing the design, we come at the results, design results, and we can switch actually to analysis results and design results from this same same ribbon menu. Okay. So design results, in which let's look at the strength check first, so we can understand if any of the members are failing or they are not good, or like there are different varieties of results that you have over here. So
Yes.
basically we can see that there is need check in green color, which means that the target ratio which you have set, you have a min-max option to set the target ratio, like minimum 0.6, maximum 0.9. So if the target ratio or the demand capacity ratio is less than the minimum target ratio, that is 0.6, if it is less than 0.6, then it will show in green color.
Okay.
Okay. And if the target ratio has been met, that means if the ratio of demand capacity ratio of your members is 0.6 to 0.9, then it will be okay. And if it is 0.9 to 1, then it is critical. And if it is going beyond 1, then it is not good. And if any of the member is pink in color, that means it is required to modify the section. So it's like really like the target demand capacity ratio is really high. So
Okay.
we need to, we can see directly from here which of the members are passing or failing. Then further we have separate ratios for the actual demand capacity ratios, bending demand capacity ratios, shear as well as torsion. So we are not performed design for torsion, that's why it's showing 0 over here.
Okay.
Okay, so that's done. Let me initialize. And we have serviceability checks as well. So there is again status, separate status for the serviceability check. Now, in the serviceability check, there is deflection check that is performed for the beams, slabs, and the columns. Not the columns,
Okay.
basically the flexural members, that is the beams and the slabs. All right,
Yes.
and also we have crack analysis for the beams and the slabs. So by default, crack ratio is shown for the beams itself. Then let's look at the results for beams. So we can see the area of reinforcement required,
Sorry,
negative
before you continue,
reinforcement. Yes, sir.
before you continue, when you were showing the crack ratios, can you go back to the crack ratios?
Yes, sir.
Can you go back to the diagram on the crack ratio?
Yeah, crack ratio. Yes.
Yes, from the diagram and then the key, I can see
Yes.
red on the third floor, and then
Yes, sir.
yellow on the ground and first floor. Why that?
Uh,
Because if we put the same loading on all the floors and the three floors are the same, I expect the moments, I expect the loadings, and for that matter, cracks on the second and the third floor to behave the same way. Am I right?
yeah, it should be the same actually, but I'm not sure why exactly it is showing in this way. Maybe because of the upper loading as well that is coming on it.
No, but the upper loading is only coming on the columns and not the beams, intermediate beams over there. It's not doing that at all. I hope you
Yes,
understand
sir,
me.
that is right.
Yes,
Yes, I understood that the result should be the same for all the levels.
exactly. I expect that to be for all the, especially the beams and the slabs. But somehow we have a different for the last but one floor.
Yes, sir. There must be some difference in the loading that I have applied on this floor and the other two floors. Need to check with that, sir, why there is a
No,
difference.
I thought we put the same loading there.
Yeah, we actually applied two loadings over here and then separate loadings on the other locations, but again that should be the same.
Exactly.
And we have over here just the additional cantilever plate, but
Nothing but
that
the
also should not make much
shouldn't affect
difference,
it
right,
too
sir?
much. Yes, yes. Normally when I'm doing analysis and I come across such a thing, then I get worried,
Right, sir.
especially using a
But
software. Then I try to investigate why it should be so.
yes, yes, that is right, sir, actually. I mean, that should be done before you go ahead with the results.
Exactly.
So no problem, sir. I'll look actually why this is the
Okay, you
reason.
can look at it and then later you let me know. That's all. Let's go
Yes,
on.
I'll let you know, sir.
Okay, thank you.
Okay. So we can also look at the results separately for the beams. With here there is a crack as well. So we can see the crack ratio. Now it's same for all. It's
Okay,
separate for the beams.
okay,
So that's the ratio negative and there is this positive one. So yeah, there is difference in the positive crack ratio.
yes,
Yes. So need to check with this. That's the
okay,
demand and that's the capacity.
okay.
Demand looks the same.
Yeah.
Capacity is I'll check with it, sir. All
Okay,
right.
thank you.
So that's one thing. And then further, there is a short-term deflection ratio as well as a long-term deflection ratio as well. And we can look at the area of reinforcement required, negative and positive, the rebar ratios for the negative and the positive. And there is linear creep results that can be also provided by the program. Alright, so these are the various design results for the beams, and similarly we can get the results for the columns. So these are basically, we can also here get the stresses, the tensile stresses and the compressive stresses for the columns. So this is how we can maybe look at these results and choose to apply the stiffness factors if required. Then separately we can also see the rebar tensile stresses. Alright, and further, strong column weak beam ratio mostly will be applied when we have utilized the capacity based design. So that's not utilized over here, and since our seismic region is not that big, I've not utilized it. So I'll go ahead with the next result, that is the 2D flexural member. We have plate elements over here. So there is plate that we had utilized for the cantilever member. So this is the result for this 2D member. So that is the bending result in the y direction, positive as well as negative. Then we can also get the shear check. The shear will be applied only when there is like a point load on your plate elements. So that's the shear check. Alright, then further we have the members for flat slab. So this is again the ratio for the flat slab members, bending in the x direction, negative, and separately for the positive. Similarly in the y direction, negative and positive. And we can look at the shear check now over here. So the shear check is performed because we have the columns. So there is y direction and x direction shear check that is performed by the program. And we can see the two-way shear check as well. So the two-way shear check is actually failing for these columns right over here, which are red in color.
Yes.
Okay, so that's the thing. Then the reinforcement, so here it will provide us with the area of main reinforcement and the ratio of rebars. And yes, these are actually the same results as you can get for all the different types of members. So similarly for the foundation as well, over here we will get the result. Now let us see how the rebar arrangement is done by the program. Alright, so I'll initialize the structure and we will go.
Before you continue, concerning the results, you realize that the far end, the column along grid line E, the column at the back there, we had a few columns failing. Am I right?
We have few columns failing, yes.
Failing, yes. I thought if the columns are failing, the program should automatically increase the reinforcement in the column to satisfy it, to make it pass.
Yes, sir. But the reinforcement that is allowed for it to be applied is dependent on the design parameters or design settings. Like over here, if I go to the design settings, I go to the rebar. Now over here, rebar arrangement is there, and if I go to the columns, then the spacing, it will check for the spacing, and it will check only with this diameter, utilize this diameter of rebar. And also this is the diameter for the shear reinforcement and the default spacing of 300 mm. So this is what it will apply basically, and then it will provide us with the results. So if it is like if the requirement is going beyond the available arrangement, then it will show not good.
Oh, okay.
So let's look at the results now. Like the rebar arrangement, and from here itself we can understand why it is failing. Alright, so we'll go to the RC section over here, and these are the critical in shear, but you're talking about columns, so let me take you to the columns. And we have over here the not good columns, and we have failure as well. All right. This result,
Yes.
as you see over here on the screen, is for the members having the same section property and the same group. So this is one result. Another result is by each and every individual member. So we can see which member is actually passing or failing. So we have few members that are failing. All right. So we can look at the results only for those which are like not
Failing.
good. Yeah,
Okay.
failing. So this is the result for the failure. Why they are failing? So there is one column which is failing because of axial load. So there's high axial stress, axial load on it. Then there is concrete tensile stress ratio that is going beyond 1. So we can see that part. Now let's look at the detailed result. Yes, sir. Let's look at the detailed results. So we will check on this option and we will see over here which member it is actually. So we can see it is highlighted right over here. Okay. And we can actually generate a design report of that member. So I can, okay, let me go back to the RC section right over here. Column, member, and unselect all and look at the not good. Okay, so it's a 2F, column number 929.
Okay.
All right, and instead of going to the detail, let's directly take a look over here itself, the reason for failure. So basically the demand is 40.6 and the capacity is 9.25. So that is the reason for the failure. And this is only for the axial. Otherwise for bending it's okay in the Y and Z direction, and shear also it's okay. So that's one thing. Also there is concrete tensile stress result that is failing for the rest of the members. Otherwise they are all passing when it comes to axial, bending and shear. All right. So that's one thing. This is checked on.
Okay.
And now let's take a look at the, this is the one. Okay. So for this, let's take a look
I
at the
think
detailed
our
result.
columns the same size. Our columns, are they the same sizes?
Yeah, they're all the
They are
same
not,
sizes
isn't it?
except for this one. It's going, this is actually having a regular shape. Again, one thing I have not told, actually I'll mention that as well. So we have over here, remember type, I'll make it to ng. Okay, now here as well I can do the modification of the columns. All right. This is, okay, this is the irregular column actually that we have. 2F level, column 29. That's the rebar arrangement that we have over here is 13-P16. So this is the arrangement of this irregular column. So this irregular column is basically failing.
Okay, is the irregular one.
Yes, sir.
Okay.
Hello?
It's okay. That's the one failing. Hello, I can hear you.
Sorry, sir. I could not get you actually. Can you please repeat?
I said it is the irregular column which is failing.
Yes, yes.
Okay, okay, okay. The size is 0.23 by 0.71.
Yes, that is
That's
right,
the
sir.
size. And the other sizes are 0.4 by 0.6. Am I right?
Yes, sir. That is right.
Okay, that's why it's failing. Okay, okay. Let's
Yes.
go on.
Okay, so in case you would like to do the modification, you can change it from here itself, like the diameters and then the spacings as well for the hoop and for the main rebars as well. So by the pattern, number of diameters, number of bars and the diameter can be modified. Okay. So that's one thing. We can also look at the other column sections. I think all of them are irregular itself. Yeah, I think we can see them highlighted. This one is rectangular. Yeah, this one is rectangular. This one is also failing.
It shouldn't fail.
Yeah, it's actually a lot of bars have been applied, which is 10 at, 30 numbers, 16 number of diameters. Okay, it's actually a huge amount.
And why is it failing?
Okay.
It shouldn't fail. I don't expect it to fail.
We can take a look at that, sir. Actually, it's this particular member. So let's look at the detailed design report of that member.
Yes. Yes. Let's see what is happening.
Yeah. So for this member, let's go for the design report generation, detailed design report. And the column is already selected. So that's done. And we'll click on OK. The program will create a Word file. All right. And here we go. We have the result, actual load, bending,
Where's the actual load?
ratio.
Okay. Okay.
Okay, so basically we have over here the slenderness ratio check. The column is slender. And okay, let's look at the results.
Okay.
Shear capacity is passing.
So it's okay. Need check.
This is also okay. And shear is okay. Middle shear is okay. It was actually failing because of the stress. So yeah, stress limitations were there. So because of the stress check, it was not good. It's saying not good. This is tensile stress. So 3.066 is the tension that is there, but the capacity is 2.8 to 1. And this is the formula used for the stress capacity.
Okay.
Yes, that is the reason why it is failing. All right, sir? Hello? Is this fine, sir? Shall we go ahead? Yes, sir.
So I'm trying to check why it's failing.
Oh, it's showing that it is failing in stress.
So I'm trying to check why it is failing. The stress is 1.07. Let's go ahead. Go ahead. Okay. I'll go. Yes. I can go ahead. I can also look at it later. We can go ahead. Okay.
All right, sir. So we are done with the design part. I mean, similarly, we can check the design result for the beams, for the flats, slabs, and for the slabs itself. Now, let's go ahead and generate drawings. So we'll go to the report and drawing tab, and we will click on this settings first, and we will see which all drawings will be created by the program. So we have the column layout, which will be created by the program for all the levels, start level to the end level. which we can modify as well. All right, and further we have all these plans that is at all the level. So that will be again created by the program, and the rebar arrangement also for each and every floor level. So after we are okay with these results, we will go to click on generate drawing. This will open MIDAS drawing software
Okay.
again.
Okay.
Alright, so we are at the MIDAS drawing, and now we can click on this drawing creation right over here, and we will go to the setting for the structural drawing. Now this setting for the structural drawing is basically the location where you can specify how the display of the column should be. You want to display the dimensions on the floor or based on the level. Like depending on different options available over here, you can see different types of drawings. So once you see which these drawings, what these drawings are going to give you, then you can select these for which is going to be suitable for your daily usage. So once these settings are done, you can simply from next time onwards, no need to do any modification. These settings will be kept like these itself.
Standard.
Okay. All right.
Okay.
So that's the thing. Then various options are there. Let's look at them one by one. So firstly, whatever the default settings are there, let's see the drawings for that. So drawing creation will go again here to generate structural drawing overview, which will give the entire information of the structure that we have. This includes the general information like the project name, structure name, site location, everything is like available in this format. You can do the modification or write a text over here just like you do in AutoCAD. So all the AutoCAD commands are available. You can use them over here. Okay, so general information like the codes that you have utilized, material properties, rebars that have been utilized, and the material or the grade for the rebar, everything has been specified right over here. All right, next is, let's take a look at the structural plans. So we have floor plan tab over here. Now instead of having a look at all these floor plans, let's just select one floor plan. Let's say this one, that is at the 4F level. Okay. And we can change the scale also and just click on confirm. After we click on confirm, the program will like make a box, and we have to place that box wherever we want to create our structural plan. So I'll just wait till this structural plan is being created. Okay, so we have got our structural plan. I'll place it anywhere right now over here. Now in the structural plan, we have got over here our slab as well as we have over here our beams. Okay, and we can see the names as well provided to the beams. Let me also open up a structural plan for the flat slab, and we'll have one for the lower slab itself. Confirm that and place it over here and here. Okay, so this is the actual drawing for the the first level, 1F level. We can see the columns, the beams, then the slab information. Wherever I have created the design group, at those locations itself I can see the slab. So I had only created 2 design groups for slabs. So that's why it is like showing right now in blue wherever there were slabs which has no definition of design group. Alright, so design group is actually very important when it comes to drawing creation. Okay, so that's one thing. Then
Okay.
generate framing sections. So in this case, we need to simply like specify how the name is going to be. So firstly, the name is created. Then I'm providing over here the section. So this is the section that I'm creating. I've clicked on this and that's it. So this is the section line, and according to this section, we have over here the location of beams. So we can see right now the cross section of the beam at the location at wherever the cut lines are. So this location, this and this, and also we can see over here the slab at every level. So we can see this is slab and slab over here. These are the 2 slabs for which we had given the design group. Otherwise, it has given no name for the flat slab. Okay, so design groups are very important. Alright, after that, again we can click on over here and we can generate framing elevation. So in the framing elevation, basically you can like select the grid line and then you can right click and specify from which direction you want it. So I'll click over here, and from here to, let's say, the rest of the region, I want to create the framing elevation. And this is the elevation that we have now from to look at our structure from that location, from that grid line. Okay, so wherever you want the elevation, you can draw it with the help of specifying the location and the direction. Then we have create member list to see the reinforcement. Now here again we have different styles. So how do you want to like utilize this drawing? You can take a look at the first style. This is the information for the column. There was one type of column itself. So for one group, it has given us one drawing. And here we have the beam list. So there is 5 beam 1, 3 beam 1 and 2 beam 1. These are the group names. And accordingly, what is the section property and the reinforcement arrangement. So we can get basically the sectional arrangement along with the stirrups arrangement. And we have the slab list over here. In case of slab list, the program will provide us with the typical drawings, the typical type of drawings, and it will specify over here in the table format what is the type of the slab and what is the thickness, and then further what is the reinforcement arrangement. And the reinforcement arrangement that you can see over here is depending on the information given under the type E. So we can understand that the straight lines, that is continuous lines, are x1, y1, whereas the dashed lines are x3 and y3, and accordingly we can look over here in the type C how the arrangement is going to be. So by default, the type C is utilized, and in case you're utilizing any other type, then you can just modify the type from here manually. And this is again for the plates. So wherever you have plate design at those locations, you'll get a typical drawing, and according to this typical drawing, it is required for the user to take a look at the table and then accordingly, you may assign it to the structure on site. So these are the drawings that can be generated by the program. Hello?
Hello, I'm here.
Yes, yes. Sir, were you able to see? You have any questions?
Yes, my first question is, let's look at the column drawing.
Okay.
Let's zoom it and see the column drawing.
Yes, sir.
Zoom the column drawing. No, on the elevation. On the elevation.
Okay.
Your elevation drawing, the column, yeah, this one. Okay. Okay. So the program gives a typical section, or a section, isn't it?
Yes.
We don't have the reinforcement in the columns running up.
Yes. I mean, the longitudinal reinforcement arrangement
Yes,
is not yet here.
it's not shown. Okay, how about the beams? The same thing. It's not shown. The horizontal reinforcement or longitudinal in the beam is not also shown.
Yes, sir. Actually, for now, it's not, but it will be incorporated soon because we already have it in MIDAS D shop, which is actually utilized for MIDAS Gen software. So since MIDAS Drawing and MIDAS nGen are new software solutions, we are still developing them. And those longitudinal rebar arrangements will be included very soon.
Okay. Okay. And then can we go back to the drawing again? The 3D.
Okay.
Our model.
Model, yes.
When you look at the beam on grid line 2, is it grid line 2? Yes.
Yes. Mm-hmm.
Beam on grid line 2. Can we have a detail? What will be the beam on grid line 2? You can see it. Is it grid line 2? No, it's grid line. I think grid line 1, not 2. Beam on grid line 1.
Okay. Yes.
Can we show the detail? They have 1, 2, 3, 4 spans. Can I see the detail for that one?
For which one, sir? I'm sorry, I did not get a question.
On grid line 1. Yes, this one. Yes, especially this side. Move to the next where you are. Yes, I want the detail for that area.
Okay, this is like floating column. That's the reason, sir?
I beg your pardon.
For the floating column, because we have a column resting on it.
Exactly. So I want the detail for that beam. I want to see how it is. Is that because that one is a floating? You are right. That's why I want to see what is there.
Okay. So you would like to see the design result of that, sir?
For that one, and then the beam above it. That one and the beam above it. That's all. These two beams.
Above it, these beams.
Yeah, the next one. Come to the next level.
These beams?
That one and the second, the down one.
These ones. Okay.
Yes, yes, those beams you have selected, yes.
All right, sir. Let's take a look at in the form of table.
That's fine.
Design. We have total design results for selected members. These are passing. The ratio for these two beams is 0.66 and 0.858. So let's take a result, total design, RC beam design result. Okay, for selected ones. Okay, so this is the design results, sir. We have the bending ratio and demand capacity, and we have for the shear as well. So for the shear, it's 0.66. This beam this one, which
Yes,
is
that's
like
a bit.
highlighted right now over here. So this one is having higher shear requirements. So it's
Okay.
0.858.
It's having a higher share. Compare that one with the one above it.
Okay. I'll select this one as well. And
Are they not
this one.
are they not the same thing?
How do I know what's up?
Yeah. I want to check whether those two they have the same share the same ratios.
Yeah. This one and this one, they have different ratios, sir.
Why? Again, why do they have different ratios?
Because, sir, the column is floating and it is resting on the beam, so they are going to have different
Which
ratios.
one is resting on the beam?
So this column is resting on this beam, so that's why we have this ratio as 0.858,
How
and
about the top one?
the top one is 0.971.
Okay.
We can see the demand and the capacity as well over here, sir. The demand is higher on the upper level, and yeah, the capacity is 120, which is same for both the levels. So the capacity is
Both
same for the
levels,
upper
the
beam
capacity,
as well as the lower beam.
they are the same capacities.
Yes,
They
same
are not
capacities.
same capacities, but the demand for the upper one
Yes, demand for the upper
is
one is higher and demand for the lower one is lower.
rather. I thought demand for the upper one should be lower than the lower one because all the
Yes,
loadings are coming down.
yes, I agree with that, sir. Actually,
So what is
let's
happening?
let's look at the other two beams. So this beam is 79 and the upper one is having 83. 79 and 83. Actually, the shear force for the lower one is actually coming less totally.
Okay, maybe we'll investigate that also. It's okay.
Yes,
Let's
I'll take a look at this one as well, but it has to do something with the analysis, like how the load transfer is taking place between different beams right over here and on the upper locations. So of course there is going to be a solution for it, like the reason for it. So I'll check with it and I'll get back on this. I'm making a note of all these things, sir.
okay, that's good. That's good. Okay.
All right, sir.
Okay. Thank you very much. Thank you.
All right. Thank you so much, sir. And if you have any questions, sir, please email us and we can maybe
I'll
have
do
another
that.
session for that as
I'll
well.
do that. I'll go through the process again, and if I have questions, I'll email it to you.
Yes. Thank you so much, sir.
Thank you so much. Thank you. I
All
appreciate
right,
this.
sir.
Thank you very much.
Yes. Thank you.
Okay.
Okay. Have a great day, sir. Okay. Bye-bye.
Thank you. Thank you. Thank you. Thank you. Thank you. MIDAS, thank you very much.
Yes.